we're starting a mini unit about limits. Now, limits is the first unit you learn in calculus, whether it be AP calculus or calculus at college. That's to be the first thing you learn about. So ending the year in pre-cal with the limits should help any of you that are taking either of those courses in the coming years kind of have a head start, okay? Now, there are some things you have to remember from the past. So Learning Target 1 is actually not about limits. Learning Target 1 is about piecewise functions. And we actually covered piecewise functions during the first semester. Towards the end, we did a mini unit on special functions. So I'm only going to do one example today because we've already learned this. And so if you need to review, you can always go back and check the mini unit on special functions and watch that Learning Target 1 video, which is also about piecewise functions. So this is just a quick review today. So remember, a piecewise function has different sections, and you have to graph all the sections. You won't be graphing piecewise functions when we talk about limits, but you will be looking at piecewise functions to determine limits. So that's why we need to make sure we understand them. So in this function, I have 3 separate pieces, and I need to graph all 3 of those pieces. Then after I graph them, I'm going to evaluate the function at 3 different places here that I established, okay? So you just do this one at a time. So pretty much this is saying that we have the equation y equals 1, which is just a horizontal line at 1, if x is less than or equal to -2. Again, make sure you're watching your symbols. This is less than or equal to. So that means if I put in a bunch of x values that are less than or equal to -2, -2, -3, -4, -5. Again, remember, it's always important you have to use those endpoints when you're graphing, okay? If I put those values in for x, it just says y equals 1. So no matter what the x value, y is always 1. So we can graph this function. -2, 1. That's going to be a closed circle because this is less than or equal to. -3, 1. -4, 1. -5, 1. And so on and so forth. So we have a horizontal line that continues on for all x values that are less than or equal to -2. Then we're done with that part of the function. We don't have to worry about it anymore to graph. So it is finished. So now we do the next part. And since we have the equation y equals 2 plus x if x is between -2 and 3. You have to include those endpoints when you're graphing that. So I'm going to start at -2. I'm going to go to 3. Do you have to include everything in between? Not really. But you definitely have to have those endpoints. All right? Even though this says less than, that means we're going to have an open circle there. So you still have to have the endpoints. Some of you guys, when we did this back in semester 1, you wouldn't include the endpoints, so you're lopping off part of the equation. All right? And that's not good. So we're going to substitute these values in for x. So 2 plus -2 is 0. 2 plus -1 is 1. 2 plus 0 is 2. 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. Now at this end, we have less than or equal to, so we'll have a closed circle at that value. Otherwise, the line in between is going to be connected. There's not open circles over the entire line or anything like that. So -2, 0. There's an open circle. -1, 1. 0, 2. And then we have a closed circle at 3, 5. I'm going to connect those to show that we have a line between those two boundaries. Again, then we're done with that part of the equation. Now we just have one part left. So now we have 2x if x is greater than 3. So that's the equation y equals 2x. And that is, again, for x greater than 3. We still have to use this as an endpoint, though. So we still need to put 3 into our table. We'll just have an open circle. So greater than 3 is 3, 4, 5, etc. So 2 times 3 is 6. 2 times 4 is 8. And 5 times 2 is 10. And I'm going to graph those points, again, with an open circle at 3, 6. So at 3, 6, I have an open circle. 4, 8. and 5/10. And this keeps going on as all x is greater than 3. All right, so there you go, piecewise function. Now, we've graphed all the pieces. So now we don't have to worry about graphing any more pieces. That is finished. That is the actual graph of this piecewise function right there. Okay? It is a function because it passes the vertical line test, right? We have some overlap, but they aren't two actual points. You have an open circle and a closed circle on those. So we do have a function. But then we should also be able to evaluate by looking at this graph. So that's what we're looking at down here in this section. If I ask you to find f of 20, that means you stick 20 in for x. The problem is there are 3 different functions here. So you have to figure out where 20 falls in each of these boundaries. And once you figure out which one it does, then you use that equation to evaluate. So 20 is not less than or equal to -2. 20 is not between -2 and 3. 20 is greater than 3. So I'm going to use this function to evaluate. So I'll have 2 times 20, which is 40. So for f of x, if I put 20 in, I put it into that section only. So f of 20 is 40. Same thing for -5. You find which boundary it lies in. -5 is less than or equal to -2. So I'm going to use that first equation. It just says f of x equals 1. There isn't an x to actually substitute something into. So it's on this line. So at -5, we would still be at 1. So that doesn't change. All right, and lastly, I have f of 3. So 3 is not less than or equal to -2. 3 is between -2 and 3 since it says it's less than or equal to. So this is the one we use. We do not use this one. That's for x is greater than 3, not greater than or equal to 3. So we use the second equation. It says 2 plus x. So I have 2 plus 3, and that's 5. So on the assignment today, because this is just a review, we've done this before, you need to graph all the functions and then ask you to evaluate for 2 different values, I'm pretty sure, or maybe it's 3. Okay? That's all you're doing. You're reviewing that today. So that tomorrow when we start looking at limits, you can look at a graph and understand what you're looking at. Okay?